Hello, welcome to AP Stats Probability Question of the Day, number 3. This one's from 2013. This is by far my favorite AP Stats free response question ever. I know how nerdy that sounds, but this one is just beautiful. So we have eggs, egg cartons, one randomly selected cardboard container, 12 randomly selected eggs. The weights of such full cartons are approximately normal with a mean of 840 and a standard deviation of 7.9. So if F is the weight of a full carton, that means that F is normally distributed with a mean of 840 and a standard deviation of 7.9, which we can draw down here, 840. And then I always like to mark a standard deviation on both sides. So the standard deviation is about 8. So I'm going to call this 848 and this 832. And the question is, what's the probability that a randomly selected carton will be more than 850? So we want to know the probability that F is greater than 850, which we can mark on our picture right here. Always draw a picture. Always want to draw a picture. And you can type this into your calculator as a norm CDF. My lower bound is 850. My upper bound is a big number. My mean is 840, standard deviation 7.9. However, AP says, no, that's not good enough. We need you to convert into z-scores. So we will cut the corner by not doing the whole math part. This is what I like to do, is write out the formula for a z-score without actually calculating what it is. And then in the end, we end up actually typing this into our calculator. And we get that this area is 0.102. Let's do a little check at our picture. That checks out probably about 10% of this area. Okay, so that's not the fun part. This is the fun part, is where we're looking at the distributions of the empty cartons and each of the eggs all added together. And it really highlights this idea in statistics that x plus x is not equal to 2 times x when we're talking about random variables, because each egg has its own distributions. When we're adding them together, you can't just take double one of the eggs. My favorite way to talk about this would be the difference between rolling 2 die and adding them together would be x plus x. But 2x would be taking 1 die, rolling it, and then doubling that value. So those are clearly 2 different distributions. So when it comes to random variables, we can't just do our old algebra rules. You have to be more cautious. And just as a review, when we're combining random variables, the means add in a linear way, as you would expect them to intuitively. The variances add, but that implies that the standard deviations don't. I think of this sort of like Pythagorean theorem up here, where a squared plus b squared equals c squared. You can't separate the geese. The square root of 2 squares does not distribute through. Okay, so let's actually read the question now. So pretty much we have the weight of an empty container. We have the mean and the standard deviation of the empties. Now we want to find the standard deviation and mean for just the eggs. They gave us the full cartons before. They just gave us the empty carton info. And now we want to find the stats for just the eggs. So I've already prepped a little bit. So we want to identify that a full carton is an empty carton plus 12 eggs. But that's not, I'm going to write it here as a not, it's not 12x. No, wrong. Because in stats class, x plus x does not equal 2x. It's instead 12 copies of this variable x, because each egg has its own variation. So now we want to find the mean of x. So the mean of f, it works out really nicely here because the means work exactly how you want them to. And now, so this right here was an equation of random variables. But below, now we're just talking about real numbers. So we can use now our old algebra rules. This right here, all of these numbers, mean for x1 and mean for x12, those are all the same value. So now we can use our old algebra rules, and we have that the mean, nope, mean blue, the mean for the full carton is the mean of an empty carton plus 12 copies of the mean for a single egg. So we're looking for mu x right here. We're looking for the mean of x. So bear with me. We would subtract the mean for the empty and divide by 12, which gives us 68.33 grams. Okay, that was the easier of the two statistics to find. The harder one is now the standard deviation. So going back from this line right here, this is in our important equation of random variables. Let's bring that down and think about what happens with the variances. So the variances add in a nice way. Standard deviations don't. So our variances here, our sigma f squared is going to be just the sum of all the variances. 12 copies of this egg. So now, once again, this is an equation of real numbers. Here, this is an equation of random variables, but now we're just talking about their variances. These are just numbers. So I'm going to remind us again that these are just real numbers. So we can do our regular math with them. And by regular math, I mean algebra. This is the variance of f squared. And now all these variances of these individual eggs, now this does become 12 times the variance of a single egg. So this is 12 times the variance of a single egg. And in the end, what are we looking for? We're looking for this guy. So let's solve for that. So hopefully you can agree that we can subtract the variance of an empty container, divide by 12, which then implies that we can take the square root of both sides. We're looking for precisely sigma x. We want the standard deviation, not the variance. We found the variance here. So now let's take the square root. So the variance or the standard deviation is the square root of this whole thing up here. Can't separate the geese. Can't just split up that square root. So in the end, we want the square root of the standard deviation of f squared minus the standard deviation of e squared divided by 12. So that would be 7.9 squared minus 1.9 squared all over 12. And this whole thing is under square root. So my final answer here is 2.33 grams. Wow, I love it. One thing to note here is units. Write your damn units. Thank you. Bye.